Today we're going to look at dividing polynomials with long division. So you use long division when you're dividing by something that's not linear. So anything higher than x to the first. So let's look at our first example. We have 2x to the fourth plus 4x cubed minus 5x squared plus x minus 2 divided by x squared plus 2x minus 3. Okay, so we know we have to do long division on this one because what we're dividing by is x squared. Okay. Now, we could maybe factor this one and try dividing by each of the linear factors, but that's only going to work if we have zeros. Okay, and we don't know if we have zeros or not. So anytime I'm dividing by something that's x squared or higher, whether I can factor it or not, I always do long division. So we're going to have x squared plus 2x minus 3. Then what's being divided goes on the inside. So now for long division, we're always looking at the first parts. Okay, so we want to do x squared times what will give us 2x to the fourth. And so that's going to be 2x squared. Then we're going to take this 2x squared, distribute it to everything. So that'll be 2x to the fourth plus 4x cubed, and then a minus 6x squared. Okay. Once you distribute, okay, then we're subtracting this. So we're going to change all of the signs. So I'm going to switch all of these positive ones to minus, and that's to plus. And that's usually why I leave off the plus sign right here. Then the first term should always cancel out. Okay. This second term in this case also just happens to cancel out, but this second term won't always cancel out, but the first one should always cancel out. Then you're going to add these. That'll give me 1x squared. Then I'm going to bring down, since I canceled out the first two terms, I need to bring down the next two terms. Okay. If I have 3 terms here, I always want to make sure I have 3 terms here. Okay. Then again, we're going to work with these two terms. So it's always this times what will give you this. Okay. If you're not sure, you can always do the inside part divided by the outside part. So that'll end up being a positive 1. And then we're going to distribute that positive 1. So that'll give me x squared, 2x, and a negative 3. So distribute. Then you need to subtract this polynomial you just got. Okay. The first term will always cancel. This is going to give me negative x. This is going to give me a positive 1. Okay. So this right here is our remainder. You know you've gotten to the remainder when the degree on the inside is smaller than the degree on the outside. Okay. So our final answer is going to be the 2x squared plus 1 plus our remainder is negative x plus 1 over our divisor, which is what we divided by. So now, if you're going to write this as a minus, okay, you have to be sure. So right here, if we're going to take this negative and move it out here, we have to take the negative out of both terms. So I'd have to GCF this out and make it an x minus 1. Okay. But if you just want to leave it as plus a negative x plus 1, if you're not sure, that's fine. Okay. But if your first term is negative and you're going to write it as a minus for your remainder, be sure to factor out the negative out of both parts of the remainder. Now let's go ahead and look at one more long division example. So again, we've got to do long division because it's x squared. Okay. This time I'm missing the x term. So I'm going to go ahead and fill in a 0. So our divisor is x squared. I don't have an x. And the reason I fill in the missing terms here is because then everything will line up nicely degree-wise when I'm doing long division. So then I'm doing x squared times what to get x to the fourth. That'll be another x squared. Again, if you're not sure, do x to the fourth divided by x squared, that'll always give you what this number should be. So then distribute this x squared. So that'll be x to the fourth as 0x cubed and a negative x squared. And then we have to subtract it, so change the signs. This should always cancel out. And then you're going to add your like terms. So that'll be a 2x cubed. That'll be plus 3x squared. Okay, I canceled the first term, so I canceled one term, so I need to bring down the next term. Then again, we're doing x squared times what will give me 2x cubed, and that'll be a 2x. Distribute the 2x to all of this, so that's going to give me 2x cubed, 0x squared, and then minus 2x. So then we're going to subtract this polynomial, which will switch all the signs. This is 3x squared. These are going to cancel out, but I'm going to still write it. Okay, so because if you're missing a term anywhere in like the middle of the polynomial, you always want to write it to get everything to line up. And then I've got x squared times what to give me 3x cubed. That'll be plus 3. So this will be 3x squared, 0x, and then a minus 3. And then again, I want to subtract everything. And here, everything is going to cancel out. So I got a remainder of 0. So that means that x squared minus 1 is a factor of this x to the fourth polynomial. So my final answer is just going to be that x squared plus 2x plus 3. Now, the last thing we're going to look at is writing the equation of polynomials with specific roots. Okay, we're going to use this to move on to long division and finding the rest of the zeros eventually. So let's just look at imaginary and irrational roots. So imaginary is anything with an I. Remember, that's the square root of a -1. Irrational is anything with a square root. Okay. They come in conjugate pairs, and that's because we get those answers from the quadratic formula. And so you can see with quadratic formula, you always have plus a root and minus the root. So that's why anytime we have an imaginary or irrational root, we also have its conjugate pair. Okay. So what that means, if -2 minus 3i is a root, so is -2 plus 3i. Okay, conjugate just means you always want to write the imaginary or irrational part second. It just means change the sign between them. Okay, this part is called the rational number. You don't ever change the sign of the irrational number. You change the sign of the imaginary or square root, because that'll always be the second part of quadratic formula. So if we had these roots, we would have to do x minus each of the roots and FOIL it out. Okay, it's very messy. It takes a long time. You're going to have to do it a lot. So we have this shortcut, which is x squared minus the sum times x plus the product. Okay, so what that means, if I were to take these two roots, -2 minus 3i plus -2 plus 3i, if I add these together, the imaginary parts are always going to cancel, and you're going to get a sum of -4. For the product, you're going to take those two roots and FOIL it out. Okay, since they're always conjugates, you only have to multiply the first and the last. So that would give me minus 9i squared. Okay, and remember, I squared is -1, because I is the square root of -1, so square it, you'll get -1. So that's going to be 4 plus 9, making the product 13. So if I wanted to write a polynomial that has these two zeros, I would do x squared minus what I got for the sum, so that would be minus a -4, so that would be plus 4x, and then plus the product, which would be 13. So if I wanted to check, I could do quadratic formula here, and it would give me these two answers as my roots. So let's look at a few examples of this. Okay, so we want to find a polynomial with the given zeros. We're going to leave it in factored form using only integers. So integers, they mean like the whole numbers and their opposites. So that means no square roots, no fractions, and no imaginary numbers. So if we look here, I have -1 plus root 5. Okay, this is an irrational root because it has a square root. So that means -1 minus root 5 is also a root. Okay, it's not possible to have one without the other. Okay, this is not an imaginary or irrational one. This is called a rational zero. So they don't come in conjugate pairs. So it's just 1/2, not -1/2. Okay. So what you want to do with the conjugate pairs, you want to find the sum and the product. Okay, so when you're finding the sum, that's going to be -2. These are always going to cancel out. So the sum is just -2. To get the product, you're just multiplying -1 times -1, positive root 5 times negative root 5 is going to make your product -4. So to write the polynomial, I'm going to do y equals, I'm going to put this one first, okay, because this one's going to be linear. I know that this one is going to give me a quadratic one from the x squared minus the sum plus the product. This one right here is just going to be an x minus 1/2, but we can't have fractions. So when your zero has a fraction, the denominator moves in front. So I'm going to write the 2x minus 1 first. Okay, if you're not sure that you did it right, set that equal to 0, solve, you're going to get x equals 1/2. Then to get the polynomial from this one, I'm going to do x squared minus what I got for the sum, so minus a -2x, plus what I got for the product, which was a -4. And then this is completely factored form. Okay, this trinomial is not factorable. The only way to solve it would be quadratic formula. It would give us these two answers. Okay, let's look at two more examples. Okay. So for number 4, I have 0 and 1 minus 5i. So that means 1 plus 5i is also a 0. Anytime you have a square root or an imaginary one, it'll always be in conjugate pairs. So the sum for this one, I'm going to add these together. That'll be 2. Those are always going to cancel. So the sum is always just going to be adding those rational numbers. The product, you're going to multiply the rational numbers. You're going to multiply the imaginary ones. Okay, that's going to be -1, so that's going to switch to 1 plus 25. It's going to make my product 26. So my polynomial is going to be y equals, that'll be an x minus 0, so just an x. So if you have just an x as a factor, always put it first. Then with this one, I'm going to do x squared minus the sum, so minus 2x, plus what I got from my product, so plus 26. And that'll be the factored form. That means don't multiply it out. Now on number 5, we have two things we're going to have to do minus the sum and plus the product. So here, if I have if I have positive 4i, I also have negative 4i. So my sum, those are going to cancel out. My product is going to be negative 16i squared, which is just going to be 16. So for this one, I'm going to have y equals x squared minus 0x, and then plus the product, so plus 16. Then for this one, I'm going to have -2 plus root 7 as well. Okay, so to get the sum for these, that's going to add up to -4. These are going to cancel. The product is -2 times -2, 4, 7, or negative root 7 times positive root 7. So that's going to give me a product of -3, making the second factor x squared minus a -4, so plus 4x, plus a -3, so minus 3.